Hey everyone, Mr. Voikin here, and this is Math 10C, Lesson 2.6, Rational Exponents, Part 2. And first we're going to start off with a little bit of review. Okay, so when we have x to the m times x to the n, what is that equal? Well, it is x raised to the power of m plus n. And the opposite of that, when we have sort of division, so we got x and x raised to the power of m and n. And notice that in both these examples, the base is the same. So x and x. Okay, the powers are different, but the bases are the same. And this will become x to the m minus n. Next, if we have x raised to the power of m, and that's within brackets raised to the power of n, that equals x to the m times the n. Okay, and if I have two of them in there, two different variables, for example, and they're raised to the power of m, and they're both inside the brackets, then that will equal x to the m and y to the m. Next, what about if we have that as a fraction, and again it's in brackets raised to the power of m? That is going to be x to the m over y to the n. Now I can't simplify that any further because x and y are different bases. Just like in the example before that, I cannot simplify that any further like we did up here because the bases are different here, and notice that they're the same up top. Okay, so let's continue on with a few more of the rules that we have in our review section here. So if I have x raised to the power of a negative exponent, that is going to equal 1 over x with that same exponent, but now it's going to be positive. And in the reverse, if I've got 1 over x raised to the power of a negative exponent, we just bring that up to the top, so it's going to be x to the power of m. Okay, and so the exponent became positive and the x went up top. Now remember that this still is sort of like a fraction because it's over 1, so it did move to the top there. Okay, and the last one in our review right here is, what if I've got x raised to the power of m over n? So the exponent is a rational number. Well, the root of x, now we just got to figure out where are we going to put that n and where are we going to put the m. Okay, well, the n goes right here and the m goes right there. So it becomes the nth root of x to the m. All right, well, let's move on to the questions in this unit. And instead of doing the examples up above, I'm just going to do a couple examples from the actual questions in the assignment section. So we're on question number 1 here, and it says write each power as an entire radical. Okay, so you have to know what an entire radical is. That is when we have a radical sign with everything sort of on the inside like that. So the first thing we're going to do is take a look at example 1A here, or B, or whichever one it is that I pulled out of there. Can't remember, it could even be just similar. But we have b raised to the power of 5 over 2. Now remember, the bottom number is going to be the index and the top number is going to be the exponent that is applied to the base inside of the radical there. Okay, so we've got the root and we've got b. It's going to be the square root of b5. Now we don't write down the 2 there. It's usually just represented like such. Okay, now if they were asking me to write this as a mixed radical, remember I could pull out basically a b squared, leaving me a b in the middle. But right now, they don't want it in that form. They want it written as an entire radical. Okay, now what about the next example below that? Negative r raised to the power of 7 over 4. So when you see that negative sign, don't get mixed up and try to go 1 over r to the 7 over 4, because that negative sign is with the, well, it's in front of the our base there. It's not part of the exponent. So we only change that to a 1 over when the exponent itself is negative. Okay, now you have to notice that on the example below, it looks almost the same, except that now the negative r is in brackets. So the way that it's different is that this one right here, this first example, the 7 over 4 is only going to be applied to the r. So it's almost like this little minus sign is just sitting over here, and it's going to be part of the answer. Okay, so when we go to write our answer, that negative sign is going to be out here. Okay, and then what we're going to do is create our root. R goes in the middle, 4 would go here, and the 7 would go right there. So it's negative 4th root of r raised to the power of 7. Now let's take a look at this one down below. Now what I'm going to be doing is taking the 7 over 4 and applying it to the negative r. So that is going to equal the root of negative r on the inside. Okay, and it's going to be the 4th root, and the negative r will be raised to the power of 7. All right, well, let's move on to question number 2, and it states, simplify the following. Write each expression as a power and make sure it has a positive exponent, and then do it again and represent it as an entire radical. Okay, so let's do the first example, y raised to the power of 6 over 5. Sorry, I forgot part of this. It's going to be divided by y raised to the power of 4 over 5. So remember, when we're dividing, if the base is the same, then we subtract the exponents. So this becomes y, and it's raised to the power of 6 over 5 minus 4 over 5, which is going to equal y raised to the power of 2 over 5. So this now satisfies this first part, which is a power with a positive exponent. So we've got our power of 2 over 5, and it is or y to the raised to the power of 2 over 5, and the 2 over 5 is positive. Now it says to represent this as an entire radical, so that means we're going to root our base, which is going to be y. The 5 goes right there, and the 2 goes on the inside. Okay, now let's move down to the second example I have here for you. It says, in brackets, e raised to the power of 3 times f raised to the power of 3 over 2. Okay, so remember that what we would do here is we're going to basically multiply this and this together. This actually has an exponent of 1. So that is going to equal e raised to the power of, well, 3 times 3 over 2 is 9 over 2, and f with 1 times 3 over 2 is raised to the power of 3 over 2. And because these have different bases, I cannot do any more simplifying. So that would be the answer of that power with a positive exponent. Now, what if I was to represent this as an entire radical? Well, I've got my E and my F, and I'm going to root that, and notice that on the bottom they're both a 2, so the 2 would go right there. With the E, we've got a 9 up top, and with the F, we have a 3 up top. Okay, let's move on to question number 3. Simplify the following and write each expression as a power with a positive exponent and as an entire radical again. So let's take a look at this first question. And we've got 64 times within brackets a raised to the power of 1 over 2, and that is raised to the power of 1 over 3. So we are going to multiply these two exponents together, and that will give us 64 raised to the power of 1 over, 64a raised to the power of 1 over 6. Okay, now that would satisfy this first part, and to write this in radical form, we're going to have 64. We will root the a, and the 6 would go here. The 1 would go on the inside. However, we never write the 1 right there. So we basically have 64 sixth root of a. Okay, now let's take a look at the bottom one. On top, I can't really do any simplifying up top right now, but I can simplify something on the bottom. So I'm going to keep this as a cubed b 1/2 right here all over, and I'm just going to rearrange these so the letters the stack above on top of each other. So we got that b to the raised to the power of 3, and I'm going to leave that right there, and the a is raised to the power of 3 over 2 and then squared. So again, I would just multiply those two together, which is going to give us a raised to the power of 6 over 2, and 6 over 2 simplifies down to 3, so that would be a to the 3. Okay, now because we've got a fraction here, we're going to first take a look at our a's, and we've got a to the 3 over a to the 3. We're going to subtract those exponents, so it becomes a to the 3 minus 3, which is a to the 0, and we know that anything raised to the power of 0 is just 1. So essentially, these two just sort of eliminate each other, and we end up with a 1, but again, we don't need to write that. So now I've still got this b. It's raised to a half. A b raised to 1 over 2 all over b raised to 3. Now, because it's a fraction form there, we need to subtract those exponents. So we know to subtract exponents, we need to have a common denominator. So I'm just going to rewrite this with a common denominator. So it's b to the 1 over 2 all over b to the, now how do I express 3 as a half, with an exponent of 2, that would be 6 over 2. So now I've got b to the 1 over 2 divided by b to the 6 over 2. I'm going to subtract those, so it ends up being b to the 1 over 2 minus the 6 over 2, which is going to equal b to the negative 5 over 2. Now, does that meet the requirements of the question, a power with a positive exponent? No, we have a negative exponent. So how do we deal with that? Very simply, again, referring back to our rules, we simply put a 1 over, move the b to the bottom, and change that exponent into a positive value. So now there it is as a written as a power with a positive exponent, and gotta be careful even writing it like this. That 5 over 2 is getting a little bit too big, so we can resize that. It should be a little bit smaller right there, like such. That looks better. Okay, now we need to represent this in radical form, so that is going to equal, again, 1 over, we're going to root b, and we've got a 2, which would go up front, and a 5, which would go on the b, but again, we don't need to write the 2 there because we just assume if there is nothing there that it is a square root. So the answer in radical form would be 1 over the square root of b raised to the power of 5. All right, question number 4. Write each radical. So it's already a radical, and they want us to write it as a power in the form of a raised to the power of n, where n is an element of q. So n is an element of q. And what is q? Well, q is a rational number. And remember that rational numbers just have to be in the form of a fraction, and that can also be a negative fraction. So it doesn't necessarily tell us that it has to be positive or negative. It just says to make that exponent a rational number. Okay, so let's take a look at the first one. So the 5th root of a to the 4. So we know that we've got a, and we're basically going to have this rational number up here, and we're just working in reverse from what we did before. So basically this 5, the 5th root, is going to go on the bottom, and the 4, the exponent on the inside applied to that base, is going to go up top. So the answer for that one is going to be a raised to the power of 4 over 5. And the second example down below, essentially we've got a fraction here with a radical on the bottom. And so let's deal with that radical first, and we'll put it into a power form. So I've got a, again, that's going to be raised to something, and what is on that a? Well, it's a 1. Right? So the 4 that's out front goes on the bottom, and the 1 would go up top. So written as a power, it is 1 over a raised to the power of 1 over 4, except it's telling us, it didn't tell us to put it in the form of 1 over a to the n. It said put it in the form of a to the n. So that means we need to take this and change it into the form that they want us to put it in, which means I'm just going to go a, and I'm going to bring that up to the top, right? So that exponent that's on the bottom and is positive is now going to become negative. So the answer is a raised to the power of negative 1 over 4. And don't forget there sort of is that a over 1 here, so you can see that we basically put the 1 on the bottom and moved the well, we didn't move the 1 to the bottom, we just moved the a to the top and converted that exponent from positive to negative because it was moving, and there sort of still is that imaginary 1 on the bottom right there. All right, well, we're getting closer to the end. We're on question number 5. So it says, write as a power. So it's not in the form of a power right now. So we got to get it there. And then it tells us to actually evaluate it, which we can do because instead of having variables in there, we have actual numbers. Okay, so let's first transform this into a power. And I'll just do that up here, and that would become 1 over 625, and that's going to be raised to a power. And where are these numbers going to go? Well, the 4 goes on the bottom, and the 1 that is on the 625 would go up top. So as a power, it is written as 1 over 625 raised to the power of 1 over 4. Now that's if they want it in the form where the exponent is going to be positive, and if they wanted it sort of in the form like the last question where it was a to the power of n, we would write this as 625 to the negative 1 over 4. Now, what happens if we evaluate this? Well, again, that's going to become 1 over, and basically, is 625 a perfect power of 4? So I look and try and see, well, what is 4 times 4 times 4 times 4, or 3 times 3 times 3 times 3, or 5 times 5, 6 times 6, etc. And if you know your fourth powers, which most of us don't, but you should be able to recognize that it ends in a 5, so the most likely candidate is 5. So if we were to go 5 times 5 times 5 times 5, does that equal 625? Okay, well, 5 times 5 right here, that is going to be 25 times 5 times 5, 25 times 5. If I deal with those two next, is going to be 125 times 5, and 125 times 5 is 625. Oh yeah, so we basically end up with 1 over 5. Okay, question number 6. Write each expression in the form a x to the power of n, where a is part of a integer, so a is going to be an integer. Okay, so, and n is a rational number. Okay, so let's take a look at the first one, which basically states the fourth root of 81x raised to the power of 3. So what I want to do is see if I can pull that 81 out of there, first of all. So is 81 a perfect power of 4? So again, I want to check 2 times 2 times 2 times 2, 3 times 3 times 3 times 3, 4 times 4 times 4 times 4. I know it's not 5 because that was done in the last question. 4 would be too much. So again, we're going to want to sort of check out what is 3 times 3 times 3 times 3. Well, 3 times 3 is 9, and 9 times the 3 is going to give us 27, and 27 times that 3 is going to give us the magic number of 81 that we're looking for. So yes, I can pull that 3 out of there. Now, what I'm going to be left with is 3 raised to the fourth power, or sorry, the times, or 3 fourth root of x cubed. Okay, now how am I going to deal with that one, the fourth root of x cubed? Well, we'll just sort of, for a moment, just sort of ignore that 3 is there, and that's pretty simple to do. We've done questions like that already. So that is going to equal 3, and now I just take the x and raise it to a power. Well, what numbers are going to go where? Well, the 4 is the index, it goes on the bottom, and 3 is the exponent, it goes up top. So the final answer for that example is 3x raised to the power of 3 over 4. Now, the 3x is not in brackets, so remember that this power right here is actually only being raised to the x, not to the 3 over 4. Okay, let's take a look at the second example right here. Now I've got in brackets, nothing can really be done inside the brackets at this point other than changing that radical into a power form there, but let's multiply these two. No, I think it's actually better to change that first into power form. So this would be x, we'll deal with the first one, raised to the power of, well, the index goes on the bottom and the exponent goes up top. So it's x raised to the power of 3 over 4 times x raised to the power of 1 over 2. And now, what do I do when I've got similar bases? I add the exponents. So that is going to equal x raised to the power of 3 over 4 plus, now I wouldn't use 1 over 2 because it doesn't have the same denominator. So I'm going to change that to an equivalent, which is 2 over 4. So we end up with x raised to the power of 3 over 4 plus 2 over 4, which is going to equal x raised to the power of 5 over 4. And that is our final answer. Okay, last question, number 7. Write as an equivalent expression using positive exponents. So we need to create something that is equivalent, which is equal, and it's using exponents. So we'll basically be getting rid of these radicals and just converting it into an exponent form. So this one's a little bit more, well, we haven't seen this one yet. So you see that we've got in this first example the cubed root of the squared root of 8, or a raised to the power of 8. So let's just ignore this cubed root to begin with. But we can't, it's still there. But we will just deal with the square root of a to the 8 first. We'll go to the inside and deal with that one first. So that is going to equal a raised to some power right here. Well, what power is that raised to? Well, the 2 goes on the bottom because that was the index, and the 8 goes up top. Now, we can see that 8 over 2 is the same thing as a raised to the power of 4. Now, don't forget, we can't just stop right there because, hey, there's that cubed root that was out here. So I now have the cubed root of a to the 4. And again, we're just going to follow the same rules. I've got a raised to the power of what? Well, the index was 3 and the exponent is 4. So our final answer is a raised to the power of 4 over 3. Now the next example is pretty similar. It's just the cubed root of the fourth root of x raised to the power of 2 over 3. So same thing, we're going to ignore that cubed root and we're going to deal with this x that is in here right now. So it's going to be x raised to the power of 2 over 3, and that is going to be raised to the power of 1 over 4. So now what do I do with these two? I'm going to essentially multiply those together. So I'm going to end up with x raised to the power of 2 over 12. And that can essentially be, well, I'm just going to take my eraser there and reduce this right here. 2 over 12 can reduce down to 1 over 6. So that's not finished. Don't forget that cubed root is still there. So now I've got the cubed root of x to the 1 over 6, and that is going to equal x to the 1 over 6 raised to the power of 1 over 3. Again, what do? We multiply those two together, and we have a final answer of x raised to the power of 1 over 18. That is it. We are done this unit. Now it's a matter of moving on to the rest of the questions in the assignment section. And don't forget to check your answers as you're going along to ensure that you're doing it properly. And if you're doing it properly, keep on going. And if you're not, stop, examine what you've done, and try and figure out where you're going wrong.